In one of your homework problems, you have this exact relation defined. And the rest of the problem, which I'll just state, says to select all the properties below which R satisfies. So you're given reflexive, anti-reflexive, symmetric, anti-symmetric, transitive, or none of the above, and you're to select which of those, and it could be more than one, and more than one answer could be correct, which of those properties that this relation satisfies. And I don't want to go over the answers to the problem, but what I want to do is talk about how this is related to what the previous videos that I've done. Now, in the previous videos, I've always given some finite set A, whereas in this case, A is equal to the integers, which is an infinite set. And so the issue is that I haven't shown you anything with infinite sets, and I want to show you what I would do to reason about whether or not a relation, this given relation on the integers satisfies which of these properties. All right, and so what I would do is I would pick a small subset of the integers and play around with that graphically, and then think to myself, if my smaller subset satisfies one of these properties, will the bigger set, the integers, satisfy all these properties? All right, and so I'll give you an example. I'll show you with that. Okay, so let's say, remember the integers something like that, right? So let's just pick a small subset of that. Let's just pick 0, 1, and 2. So let's say A is 0, 1, and 2. And now we're using the same relation, this relation here. A is related to B if and only if A is less than B. All right, so if A is less than B, then they're related. So in this small example, let's see, we got 0, 1, and 2. All right, so let's first go through reflexivity. So think about reflexivity or reflexive, right? This is the self loops. Now, is 0 less than 0? No, 0 is not less than 0, so we're not going to have a self loop. Same thing with 1. 1's not less than 1, so no self loop. 2's not less than 2, so no self loop. Right, is that the way it's going to be for all of the integers? Ask yourself that question. Think about that. Okay, now anti-reflexive. Anti-reflexive, right? So I'll let you think about that one. Okay, so now, and remember there's a video on thinking about anti-reflexive graphically. So, okay, now let's think about symmetry. Okay, let's say so notice that there is, in fact, an arrow from 0 to 1 because 0 is less than 1, right? 0, R1, this is because 0 is less than 1. That's true, so we have 0 less than 1. And so we have 0, R1. So, but to be symmetric, we would have to have an arrow back, right? We'd have to have some arrow back like that. Well, that would say 1, R0. Well, that means that 1 is less than 0. Well, that's not true, so that's not true, so there's no edge. Right, so then is it symmetric? It's not symmetric. Okay, so this small graph with this small example is not symmetric. So could the bigger graph be symmetric? Think about that. Okay, anti-symmetric, I'll let you think about that. Now transitive. Okay, well we also have this, right? We have 1R2 because 1 is less than 2. Okay, so now to be transitive, we would also need this one right there, right? So is that true? Is it true that if 0 is less than 1 and 1's less than 2, then 0 is less than 2. That's a true statement, right? So would this hold in the bigger set of integers? Let's see. Think about it now. Let's say negative 100. Negative 100 is less than 0, and 0 is less than 3,000. Is negative 300 less than 3,000? So try and think to yourself, would this hold for the bigger set Z? All right, and that's how I would approach these problems.